It's very good to be here. It's an honor and a pleasure. And I'm here to share the story of the company I work with, which is Stone, and how we've managed to, uh, the challenge we faced when we were developing a bank here in Brazil from scratch, and why we've chosen Elixir to do that. So my name is Victor. I'm a developer at Stone, and I think that for most people here, you obviously don't know what is Stone. So I'll have a minute or two to talk about it. Stone is the company I work for, and it's focused about financial services. So it has a payment acquire solution. Uh, it, it, it has a payment gateway, which is used through the biggest e-commerces here in Brazil. We also have payment routers when you have more than one acquire, and you have to configure automatic rules for choosing for each credit card or each type of payment, which one is best for you, or when a payment acquire is down and you need to automatically fall back to others. We have conciliation services, which ensures everything you receive and you have to pay is correct. We have also credit services. Anyway, there are many financial services that the Stone as a group provide. But as you've noticed, uh, there is no bank. And since we are providing many kinds of services, it only makes sense for us to start this. And the approach we had since the beginning was to use to create a bank that is not only meant to our users through our apps. So we have plenty of apps and integrated solutions, but also an API so that other partners, other people can integrate with to manage their own financial lives. So this was the mission that we set up to do at the end of 2017, at the beginning of 2018. And as everybody knows, usually the financial network system of any country is a very old system, very complex systems with many legacy protocols, private protocols most of the times. And it's not an integration only with the central bank. You have many other parties that we should integrate to provide the full banking solution. So when we started the mission, we needed to choose a language and a platform to begin development. Stone was mainly using Python and C# for its other services with a very good success story. So why did we choose to change that and start with Elixir, right? As I've said, Stone was already a big company with a big market share. So from the start, we had very ambitious expectations. Uh, we had an expectation of millions of transactions a day on the first year or the second year in production, with very complex and very critical business rules, right? So when you were a bank and on top of that, you provide an open API for people to manage their financial lives. If your API is down for one day, that means that your clients might have to pay interest. That means that they might have to uh, pass this downtime to their clients and things like that. So it's a very critical service we were building, and we needed, of course, 24/7 availability, which it seems like everybody needs, but it's not that easy to achieve. So from this set of expectations, although we were familiar with other platforms, and I'm not saying they weren't suited to build a bank from scratch, we wanted to try something which is known for its availability and which has a very good success stories in financial services around the world. right? We were not the first company to build financial services in Erlang or in Elixir. So we chose to make a bet on Elixir and see how it would go. Of course, by doing that, we had some new technical challenges. We had to face things that weren't faced from other teams in Stone. So I want to talk about that and how we've developed solutions for it. The first and most obvious issue is that, as I said, the financial network system here in Brazil, and I believe in most countries, has many old systems, many legacy systems. You don't change a financial network quite easily. So in Elixir, oops, sorry, the community already has very good libraries and very good support for most of the things that common back-end solutions need nowadays. For example, we have very good HTTP clients like Hackney and Finch, which is the new one. It seems very promising. We have very good JSON parsers, and we are very happy with the new Beam ASP that's happening on OTP, which seems to enhance the performance of JSON parsers a lot. Of course, when dealing with legacy systems, you will have to exchange files. So the famous FTP is going to appear anytime. And we have good library for FTP and secure FTP clients for backend background jobs like Oban, ActoJob, message queue, Kafka. We have good support for most of the things. But one thing which seems that the community is not yet on par with other technologies, other platforms, is most of the protocols that involve XML. So in our experience, at least, SOAP services or WS, whatever, protocols, they don't seem quite well supported currently in the community. There is hope. We've tested many libraries. We haven't had the time yet to build a library from scratch to address this problem. But we did what is very common. We used the experience we had on other services, and we've built these integration layers, right? So we have other languages and other platforms that are better suited for WS protocols and other private protocols that these parties in the network system need. And we had them as like an anti-corruption layer. The only purpose they have is to communicate. And once they've translated the messages or the requests from the protocol, they would call our core business services in Elixir through asynchronously through Kafka, Rabbit, or direct synchronously through HTTP. So this is something that is obvious, but it's okay. So you can use other platforms. You don't have to be 100% Elixir. Use what is the best tool for the job. And another point that appeared to us, which was a little bit problematic, but was a nice challenge, is old cryptography. For example, one of the systems in our financial network system needed us to use triple DES with keying option 2. DES is a very old cipher and is currently known to be not secure. But as I said, it's very hard to evolve the network, the financial network system. So the central bank and other protocols, very famous, for example, PCI had this same requirement not too long ago. It is being discontinued, but it takes a while to discontinue something so widespread. So what we needed was triple DES with this keying option 2, and keying option 2 is actually using DES with 2 keys. And so the size of the key for this configuration is 16 bytes. And when you look at the crypto documentation in Erlang, you're going to see that ciphers without initialization vector, we have DEs with electric code book, which would suffice to us if we only used one key, but we needed size 16. And there is no DES with size 16 built into the crypto model. So what we had to do is to implement the whole algorithm. This is something I don't advise you to do without proper people analyzing it and testing, pen testing it, and doing all kinds of conformance tests too. But it was a fun challenge, right? So this might happen, and it wasn't worth to have like an integration layer just to do triple DES key option 2. So we implemented it ourselves, and it worked fine in production currently. Another big difficulty we had in the process is Kubernetes. Kubernetes is the most, I believe so, the most used ops solution for deployment nowadays. It's what our ops team wanted, but there are many discussions about how to use the bean inside Kubernetes in a proper way. So what we did at first was to use Kubernetes as we use in any other language and any other platform, right? You leave your cluster configuration, your cluster control all to Kubernetes. So what we had was no cluster at all. We were using very traditional stateless services, and we used this division of replica sets to have different purposes. What we did was that we had the same project, so it's the same repository, Git repo, but we configured through environment variables which supervision trees we wanted started. So for example, let's say we have the service that manages cards. So to issue a new card, cards transaction, and things like that. Like most services, we're going to have an API. We're going to have background workers that we usually separate in order for them not to compete for resources. We usually have one deployment focused on monitoring stale data or stale sagas. And sometimes we have a file server, and we might have other kinds of deployments here. So this is the traditional way, I believe, to use Kubernetes in other platforms. And to do that, we had this kind of ugly code here that on our application start, we read from the environment configuration, and then we have these children for deploy. So if it is a monitor, we respond with a set of supervisors, or if it is an API, a different set of supervisors. And this would configure our supervision tree dynamically for each deployment service. Then in Kubernetes, in our famous YAML configuration, we say which one we want for each replica set. And that works. That works actually quite well. We have many services using this kind of configuration yet. The next step we did to be more beamish is to configure different releases. So instead of configuring the supervision tree in application start, we bundled OTP applications together that made sense. So we had a different application, which is monitoring application or file processor application, and we bundled in the release configuration only the applications that made sense. For example, monitors don't have a router, right? It doesn't bundle in it the application to expose APIs or to consume files and things like that. So what we did is that we built all these releases and put all of them inside the same container. So in our deployment pipeline, we have like 3 or 4 releases, each for its own dedicated supervision tree. And then in our YAML, we use the path of each release to start the Beam instance. So by doing that, we're still, with many replica sets, we're still using Kubernetes like any other platforms, but we're a little bit closer to the way that the Beam organizes applications and things like that. Well, what we are studying and what we are testing is, of course, to have Kubernetes not in our way, right? So we want to reach a stage where we have all pods are the same Beam instance, the same release, and it's all clustered. And inside the cluster, we can manage instance of applications or process through Erlang, through Elixir, built-in way of doing that. So, for example, we're testing the Horde library, which is a very nice library to so that you can have global process or a global distributed registry that you can achieve the same result that Kubernetes was doing before, but without needing the help of ops to do that, you can do it all inside the Beam. So this pod, for example, it has a single process, which is global throughout the cluster. And we have a distributed registry. We might distribute processes like this. So a pod might have 2 processes and the others might have just 1. We also have other tools, for example, the distributed application controller, which is built into the Beam, which we could use, for example, to control which nodes will have the application, effectively having the same effect as Kubernetes. But this is still in testing. We are not using that in production yet, because it's people are more familiar with the Kubernetes way of doing things, and it's the most widespread way currently. And remember that at Stone, we have a lot of people from other platforms, and we didn't want to attack the deployment pipeline strategy that is already known to a lot of people inside the company. Yet, we are in the process of changing that. All right, so how did it go? You've passed through all these minor challenges, you've built your code, and you went into production. So we had some things to work with, which I believe are common not only to Elixir, but were lessons that I want to share with you people too. We practically did not tune anything for a whole year, and we were already reaching hundreds of thousands of transactions a day, and we didn't have to tune a lot to reach that with Elixir. So this by itself had proved that we've done a very good choice. But we've had some lessons, for example. The first one is that by having many services talking with each other, it's common to see problems like DB connection error, the infamous DB connection error. And what we've learned, of course, which is obvious once you know what happened, but I believe many people do this mistake quite often, is that the best thing for performance when using Elixir with Active, Postgres, and the typical stack we have with Linux is to keep your transactions very short-lived. So a way to do that is don't ever do external requests inside them. And Acto has a very nice API with Acto Multi, where you can pass a multi-instance to many models, and all of a sudden, you don't truly care where the transaction starts, where it ends, and you may do external requests inside that transaction. And avoid doing that if you can, because what happens is if you have like many long-lived transactions, they are going to compete for the pool of connections, and we don't have many connections in Postgres, not as many as we have requests incoming. So this will probably going to give you a lot of DB connection errors. And there is a fallacy here, which doing an external request inside the transaction, usually the intention of doing that is because if the request fails, you want to roll back your transaction. But there's a fallacy here, which we learn when we are in scale, that if the request failed, it doesn't mean you didn't have any side effect on the other service, right? Your request might have failed when you're receiving the response from the other service, but it has already committed the changes it tried back there. So there is actually no, in my experience, no good reasons to make external requests inside transactions. And there are many hidden transactions, hidden requests sometimes. For example, when you're publishing a message to Reddit or Kafka, it's also a request. It's not an HTTP request, but it doesn't matter. It's a message. You're spending time inside the transaction. And for example, we had a cluster of Kafka and we had configured it with acknowledge to all nodes in that cluster. And that increased the time to publish the message a lot. So publishing the message inside a transaction is also something that will make your transactions more long-lived. And another thing that it's obvious, but you have to test and benchmark it, is don't use huge batch. Sometimes working in batch is a great benefit to performance, but you have to carefully plan that. It's, in our opinion, it was a lot of times it was better to make insertions and updates in small batches than a huge one. Instead of 100 items in a single insert, like 5 or 10 items insert, because we kept the pool of transactions available to other requests, other work being done in the same application. Another thing that might surprise you with performance in the Elixir and Erlang environment is that sometimes you have hidden NIFs. So I'm using an example from the plug library that was a somewhat surprising. The generation of request IDs was done using the crypto call, the crypto function, secure random bytes. And that function has some lock contention. So that function is implemented as a NIF, a native implemented function. It delegates to OpenSSL. And it had lock contention. So it was surprising that by removing the request ID plug from a pipeline, the performance increased a lot in terms of requests per second in many systems. So beware of that. This is something that you have to benchmark. You have to test all the time. So this is just a single example of how that might happen. And as always, I'm saying this from the beginning, you have to have telemetry in place. You have to have graphs and all that kind of insights from your production environment. This is an example of a system in production where it seems like it's running fine. We are with a good response time with the average, let's say about 40 or 50 milliseconds. And if you are truly watching your performance in your scalability, you know that this might hide a lot of information. So beware of graphs like that. For example, when you separate that graph in percentiles, you're going to see that, okay, for 95% of requests, we are processing on that time, on that average, which is good for us. But we have something that is really spending a lot of time here, which is degrading our services. So if you have the intention of serving millions of requests a day, you have to watch out for these outliers, right? So in this case, particular case, this is a call, an endpoint that performs some heavy cryptographic operations, and it is expected for it to take a while. So there was no real problem in this case. But what's important is to have always a good observability story in your production. And Elixir and the Erlang community have wonderful tools to do that. We have the telemetry library, many talks about it here on ElixirConf. We are using that, and well, this is obvious, but it's that kind of thing that you don't ever stress out at the beginning of the project. So beware. In our case, we had that expectation of millions of requests from the start. So we were always monitoring and tuning things once outliers appeared to us. And well, so was it worth it to develop a bank from scratch with a new technology like Elixir? Well, I wouldn't be here if it wasn't worth it. I think this is the obvious conclusion. And it's been so worth it that we are changing the culture in the company, and plenty of other services that we already provide in production are looking into changing into Elixir. We have like not a huge team, but we've written a lot of lines of code in terms of time. So we're almost 2 years in production, and we've already written 500,000 lines of code. This shows how productive we are with Elixir. Most of these people here weren't Elixir developers before they entered Stone. So they learned it after they were hired. Most of them, I would say like 75% of them learned it after they were hired. And it's crazy how we've achieved a very, I believe, a good scale of requests and processing time and service good service levels without actually having to care a lot to it. My experience in other platforms, other languages, we would have had problems in the way that would make us slower to get here. And currently we have a full bank in production, which is, for example, authorizing more than 8.5 million actions a day. We are sending more than 2 million webhooks a day. Those partners, as I said, from run up, we've planned it to be a public API. And it took us more than a year in production with a lot of people integrating in our API for us to have to worry about tuning and performance and scalability. And up to now, we have it very controlled. We didn't have to use crazy ideas and revolutionary ideas to build this kind of service level. So, as I said, it paid off quite well, and it's changing the way the company is looking into this platform. Other services are being are interested in migrating to Elixir and being because of the success we had with Stone account, our Conta Stone, which is the name of the product. So this is my story with Elixir in production. I hope it was worth it. I hope this helps people push it forward in their companies to justify the adoption of the Bean languages in general. So thanks a lot. I think we have time for questions.
Yeah, we have around 9 minutes. So we got one question in Hoover. And thank you, by the way, for the presentation. Really good stuff. So if Heiko is there and wants to unmute his microphone and ask the question, it is a question in... Heiko is right there. I don't know if he wants to speak into his microphone.
I can read the question here.
Okay.
Is that okay?
Sure.
So from what I can see in the Hoover app, the question is, how did you train your developers in Elixir functional programming? That is there are usually two questions people ask me when I tell the story of how we went to production with this team and this product. This is one of them. The other is how do you find people who knows Elixir or who has experience with Elixir? Uh, so, as I've already entered, we don't find. We usually hire people with good programming skills in other platform, and we train them inside. I truly believe that Elixir is a very easy language to learn. Most of the time, when we are looking for people, of course, we look for people with some Ruby experience, because uh, uh, of the syntax, and we don't actually look for people with background in functional programming, because I don't think that the functional part of the language is the hardest part of being a developer. I think, as Joe Armstrong mentioned a lot of times, it was functional by accident. It was not meant to be functional. They weren't in the process of creating a functional language. They were in the process of creating a high availability platform. So we usually train the usual way, right? We have books, we have pair programming with people that are more time in the team, and they know how our pipeline works, uh, how our tests works, and all of that. And we have no specific way that is revolutionary in here. The thing is that we've known by experience is that Elixir is a very small language with very good documentation. So this set of attributes in a platform makes it quite easy to start. And it has a very good tooling story. So the first thing we do to everybody is to install ASDF, the tool, so that they can install the versions we use of Elixir and Erlang and any other tooling. And once they do that, they automatically have mix, they can run tests. And we actually take more time to ensure people are familiar with Docker, with Kubernetes, with other things than Elixir itself. People learn Elixir real quickly. Like in 2 weeks, they are very productive already with the language. And it takes more time to help them understand how is the process of building a release and putting that into a container, making it available in other environments so that we can test their code, than the language itself. So I'm sorry to disappoint, there is no special sauce, no special secret on how we train our developers, because I think this is the easy part. The hard part is to find good people which have a very good cultural disposition, which are avid to learn. Once you do that, I think that training Elixir is not the hardest part. Many people that we've hired, they've learned Elixir to do the challenge, the technical challenge we do. We have a technical challenge like many companies, and we send them the getting started guide from the Elixir Lang website, Elixir School, and other resources so they can ask questions about. And a lot of people delivers the technical challenge, which is an API, in 2 weeks time. So they learn the language in 1 week and then start developing the challenge. And so we have many stories of people that learned the language to do this technical challenge. We know it's not a deep knowledge of the runtime and the language, but I think this is the easy part, not the hard part.
Yeah, and while you were answering that question, another one rolled in on Hoover, which is a technical question about usually Ecto transaction updates one or more tables, and then optionally have some side effect like sending message or triggering a notification. I don't know if that's a question.
I think it meant to ask how do we deal with side effects after we insert or after we update something uh, in a saga, for example. Well, uh, as I was saying in the presentation, there is a fallacy of thinking that if an HTTP request fails, you can roll back your transaction because you think there were no side effects on the other side. So this is something hard to do right. But one thing that I advise you to always do is that the reason why a request might fail, or for example, while publishing a message might fail, uh, is something that is network related most of the time. Or it might be, of course, that you have the wrong. Uh, what I mean is that if you're getting 400 like bad requests, or it's your integration is wrong. So you have to fix that. But the problem you are going to face in production usually is not like that, because you've tested before the integration before sending to production. The problem you might have is a network problem usually. And network problems, you may deal with them in code. So what I see a lot of people doing is that because they are in a transaction, they don't handle the return of a bad HTTP transaction, right? So to manage side effects, it's a hard thing to do right, but uh, what I advise you to do is you have to handle the return you get. Most of the time, if you're doing that, you have to catch errors because the library you're using might fail for unknown reasons. And you have to catch that before starting your transaction, right? So, or outside your transaction anyway, before or after.